General oscilloscopes are unisolated, with the housing, channel outer metal, and probe ground wire all directly connected to the grid ground wire. If a regular probe's signal wire is directly connected to the fire wire and ground wire to the zero wire, this is absolutely not allowed, because short circuits in fire lines and ground lines, or zero lines and ground lines, are both very dangerous. The safe and correct approach should be to use a high-pressure differential probe, which measures the potential difference between two high-pressure points without relying on the grounding of the oscilloscope. Today, we will use DISO 2D20 and DIPO 700 oscilloscopes to test the differences between 5 types of probes and demonstrate how to reduce signal amplitude at different gear positions. HT100B and PP150, passive probe with an attenuation ratio of 10:1, a bandwidth of 100 MHz, a maximum input voltage of 600 volts, and an input resistance of 10 megohms, primarily used for conventional circuit measurements. HT500B, passive probe with an attenuation ratio of 10:1, bandwidth of 6 MHz 500 MHz, maximum input voltage of 150 volts 300 volts, input resistance of 1 megohms 10 megohms. T30-100, high voltage passive probe with an attenuation ratio of 100:1, bandwidth of 100 MHz, maximum input voltage of 2000 volts, and input resistance of 100 megohms, primarily used in switch mode power supplies and power electronics. HT8050, high pressure differential probe with differential input modes, offering attenuation options of 50:1 and 500:1 with a bandwidth of 50 MHz, primarily used for high pressure floating ground measurements. At different probe positions, the key to accurately restoring signal amplitude lies in matching the attenuation ratio within the probe with the oscilloscope channel settings. Usually, when you press the CH1 button on the front panel to enter, there is a probe setting option. This setting needs to be manually matched with the current physical gear position of your probe to correctly restore and display the voltage value. Use the HT100B to measure the built-in compensation signal of the oscilloscope, which measures 4.96 volts at X1 position. Switch to X10 gear, press the CH1 button on the front panel of the oscilloscope, find the probe settings option, and set the attenuation ratio to 10x. When adjusting the horizontal base and vertical position, you can see that the voltage values have been correctly restored and displayed. Similarly, in 100x gear, set the probe attenuation ratio for the channel to 100x. Next, measure the grid electricity using a differential probe. The BNC terminal connects to channel 1, with the probe set to 500x. The oscilloscope channel's probe attenuation ratio is set to 500x. The waveform and measured data are displayed on the screen at a frequency of 50 Hz with a root mean square of 212 volts.